us.
A, 20, a 250 Newton force is applied on a block of a mass of 25 kilograms. The 25 kilogram block is connected to a 10 kilogram block by a light inextensible string through a frictionless pulley, as shown on the diagram below. The 250 Newton force acts at an angle of 25 degrees to the horizontal so that the system of the block accelerates to the left. The coefficient of the kinetic friction force between the 25 kilogram block and the surface of 0.15.
Okay, thank you so much, sir. So a 250 Newton force is applied on a block of mass 25 kg. Now this block is connected to a 10 kg block by means of a light inextensible string through a frictionless pulling, as we can see in the diagram. The 250 Newton force acts at an angle of 25 degrees to the horizontal so that the system of blocks accelerates to the left. All right? The coefficient of kinetic frictional force between the 25 kg block and the surface is 0.15. And now the first question says, we need to draw a labeled free body diagram showing all the forces acting on this 25 kg block. Okay, fine. So how do we do this? Well, we know how to do it. And here I'm just going to draw the free body diagrams for both of these objects. Remember to do that on your rough work section to draw for the other one as well. Unless if you can clearly see which forces are acting on it. Now, this is for the 25 kg block. We have the normal force because it's on a horizontal surface, a table, that is to say. And we also have an applied force that is acting at an angle. And this applied force is going in that direction. They said to us the system accelerates to the left. So then it means we actually have a kinetic frictional force, which is going to the right. And I just want you to see how the diagram is. Can you see that this 25 kg block is on a horizontal surface, but the 10 kg block is hanging vertically? Yes, it's vertical, this one. It's just hanging vertically. But even so, when you look at the tension force in the string, the 10 kg block is pulling the 25 kg block to the right. So the tension force on the 25 kg block is to the right. But what about for the 10 kg block? Now this 25 kg block is pulling the 10 kg block upwards. So the tension force is going upwards on the 10 kg block. So that's very important for you to realize. All right. So this is going to be the tension force. And then, of course, we also have the gravitational force, which is just an innocent force that's going vertically downward. Well, this is what we have. Now, let's also go and draw the free body diagram for this 10 kg block. Now, this is how it's going to look like for the 10 kg. There are only two forces acting on the 10 kg block. It doesn't experience any normal force because it's not on any surface. It's just hanging. And therefore, it can't experience a friction of any kind. So then, these are the only two forces. It's going to experience a tensile force, which is going upwards. And it's also going to experience a gravitational force, which is pulling it downward. And that's just it. These are the only two forces acting on the 10 kg block. All right. Well, you'll also say applied then. Perfect. So that's how the free body diagram is supposed to look like. And you can see there are 5 forces there, which is why the mark allocation is 5 marks. Now, this is the first question. The first question is asking us to please find the normal force, which is exerted by the surface on the 2 kg block. All right. So how do we find this normal force anyway? Well, that's easy. We have seen that there's actually 3 vertical forces here. The normal force, the vertical component of the applied force, and the gravitational force. And since we can see that our vertical component of gravity is positive, so it means we are going to use the formula that says, if you take your normal force and add it to the vertical component of the applied force, the resultant will give us the gravitational force. And now we come and say, but we want to find this normal force. And we can take this one to the other side and say, gravity is calculated by mass times the gravitational acceleration. And this is a 25 kg block. And then we can go to the vertical component and we say, well, the applied force is 250 newtons. And we multiply this by the sine of 25 degrees. And now we can press our answer into the calculator and find the normal force. So, how much do you get when you press this into your calculator? So we are simply going to get 139.35 newtons. But the question did not say calculate the magnitude. Although it's a little bit obvious, but the question said calculate the force. So when they say the force, they want the direction as well. Always assume they want the direction, and so give it to them. Well, I don't think there's a question on calculating the normal force, but this is the next question. It's asking us to please calculate the acceleration of the system of blocks. They could have decided to say the acceleration of the 25 kg block, which is still fine in the same way. Or they could have decided to say the acceleration of the 10 kg block, which you also find in exactly the same way. Now, we see that the objects are joined together by a string. All right. And so we know that the tension force in the string is going to be the same. But that's not the point. The point is we need to use the simultaneous equations. But how do we use them? By considering each object or each block separately. That's how we do it. If you go to the 25 kg block, it's going to give you one equation that has two unknowns. And the same thing holds if you go to the 10 kg block, you'll get the second equation that has two unknowns as well. And you solve that simultaneously. And it's not really true that you are solving them simultaneously, because simultaneously means at the same time, yes? And the truth is, you're actually solving for one variable first and then going to the other one. So let's consider a 25 kg block. That is really a sarcastic laugh. Do you know what's the meaning of the word sarcastic? What if you don't? I'll give it to you as homework. But the laughter I just gave you now, it is called a sarcastic laughter. All right. So then let's get to the real thing. Now, what is the real thing? We go to the 25 kg block. So remember, we are looking for the acceleration. And the 25 kg block is accelerating horizontally. That's the most important thing. And therefore, we need to consider the horizontal forces for the 25 kg. So we begin by stating Newton's second law. The net force acting on an object will result in this object accelerating. And now I'm going to choose the direction of motion as positive. In other words, I'm just going to choose anything that goes to the right, to the left, I mean, as positive. All right. So then what does it mean? It means that my F in the X is going to become positive, but my tension will become negative, and the same holds for the kinetic frictional force. And this is equal to MA. Well, let me just say the same thing, or rather one thing, and get it over and done with. Anything that goes to the left is positive, and anything that goes upwards is positive, because the direction of motion is like this. The other one is going up while the other one is going to the right. So I'm taking the direction of, to the left, I mean. I'm taking the direction of motion as positive. And this is actually what I always do. I am not sure if you are aware of that. Just that I like to say take right as positive. But in the actual fact, I always choose the initial direction of motion as positive. And I'm going to be consistent with this up until you finish school. Well, you only have one more year, but nonetheless, that's just what I'm saying. So let's go. We know the applied force. It's given to us as 250 newtons. But we want to find the horizontal component of this applied force. The tension force is not given to us. The kinetic frictional force is also not given to us. But they gave us the coefficient of kinetic friction. That's what they did. All right. So we are going to take this coefficient of kinetic friction, which is 0.15, and we times it by the normal force. And the normal force is still the one that we calculated above. And the whole thing will be set equal to the mass, which is 25 times the acceleration of this block. Yes, and if I did everything correctly, then this is what I'm going to say now. I can see that my tension is going to be negative, and I want it to be positive. But even if it's negative, that's fine. I can use the elimination method. That's fine. Yes, I'll just use the elimination method. That's fine. But in all the videos, I used the substitution method. But let's show that the method will work. So now we go to the left. And what is it we say? We say we have 250 cosine 25 minus 0.15 times 139.35. If you press that into your calculator, you get positive 205 point something. So I'm just going to take this 205 to the left so that it becomes, do I really need to take it to the left? No, because I'm going to use the elimination method. So it's perfectly fine. Hey, it's perfectly fine on the left. I don't need to take it to the right. And now we can see that we have one equation that has two unknowns. We don't know what's the acceleration. We don't know what's the tension. And so we need to resort to the 10 kg block in order to get the second equation. Moving on. So we go to the other block, which is the 10 kg block. And we know that there are only two forces acting on this block. So it's just going to be the tension force and the gravitational force. And once again, I'm going to state the principle F net equals MA. And by the way, you don't have to use the same equation twice in the same question. Do you get me? So you could have decided not to write it this time around and just go straight to the point and say, well, my tension force is going to be positive, but my gravity is going to become negative. You don't have to. As long as it's in question 6.1, for instance, and you now have to use one equation and then use it again in a different calculation, but within the same problem. You don't have to write the same formula twice. All right. Now, how do I find my gravitational force? By taking the mass and timesing it by the gravitational acceleration. And so the tension force here will just be 98, I should like to believe. Yes. And this is set equal to 10A. And this becomes our second equation. And here I'm going to use the elimination method. So in order for me to eliminate, I need to add these two equations. Why do I need to add them? Well, that's because the tension is negative on the first equation, and now it's positive on the second equation. So negative T plus T will be 0. So the tension is gone. Now then we are left with 205.67, 44468 on the left. And this is added to negative 98, which is the same as subtracting 98. And so we get 107.67, 44468. And now we go to the right-hand side. We say 25A plus 10. Well, that's 35. And now you can divide both sides by 35, yes? And you're simply going to get 3.08 meters per second squared. Well, the question here said calculate the acceleration, not the magnitude of the acceleration. So you need to tell us that this acceleration is going to the left because we chose the initial direction of motion as positive. But if the next question had said calculate the tension force, then that's easy. You can now substitute your acceleration into any of the two equations in order to find the tension force. So I took the 98 to the other side, it becomes positive. And so 10 times 3.08 plus 98. Well, then you find that the acceleration will be the tension will be 128.8 newtons. But with regards to the tension, when they say to you, and listen to this, when they just say to you, calculate the tension force, and they don't specify the tension acting on which object, then you're not going to give direction. You're not. You can't say this tension is going to upwards, in fact, because they didn't specify which object. But if they say the tension acting on the 25 kg block, you'll say right. But if they say on the 10 kg block, you'll say upwards. But if they just say calculate the tension, I know, you don't give them the direction. Because you don't know which block is it acting on. So when they don't specify which block, assume they're actually saying the magnitude of the tension.